Good afternoon, everyone, and thank you for joining. My pleasure to be with you. My name is Hisham Arafat Shahata. I'm Executive Technology Advisor and Chief Enterprise Architect working on several projects, mainly focusing over the past 12 or 13 years on AI, data science, big data, and similar emerging technologies. Next, please. This is brief about me and my LinkedIn profile in case you would like to connect and have further discussions. Next, please. Okay. So if we can just click until we finish all the animation. So I was thinking I will be sharing from my side. So the first point we have here is a kind of trying to figure out what are the challenges with AI, why AI is different from other application. And when we say the word AI, artificial intelligence, we mean actually many different things. And this is the first challenge we have. So it might include chatbots, natural language processing, robots, personal assistants, generative models, which is making quite a breakthrough over the past couple of months or several months. We have also precision agriculture, emotion detection, autonomous vehicles, machine dictation, computer vision. So actually, AI is not just one thing. It's multiple things. It's quite different things. And if you notice that there is a big difference between natural language processing and computer vision, this is the first challenge with AI. So let's have a look, very fast one on what are those, how they look like, the different domains of AI. So if we can go next, please. Next. So the first one is the perspective and real-time analytics, and this is quite important for business organizations like e-commerce, supply chain, financial services, utilities, and the different vertical industries. And these are actually quite important because they have very valuable applications at the same time not yet fully implemented. It's related to taking data from sources, applying machine learning and statistical algorithms to take action, what is called also algorithmic decision making. Next, please. Another one is computer vision. Next, please. Computer vision has different applications. One important is self-driving, which became very mature right now as we speak. Next, please. And also we have the medical diagnosis, very important as well because it adds value to the practitioners and the consultants. Next, please. We have also, if we can go next.
Yeah. Sorry, I'm just going to get on the right screen.
Okay, reinforcement models are also quite important, and they are about interaction with the environment and learning from the environment. Next, please. We have the very famous imitation learning, which is used also in self-driving cars. Next, please. Edge AI and autonomous agents are mostly used in IoT applications and stuff like robots, like drones, unmanned aerial vehicles of different types. And the idea here is that AI models are embedded into the devices, so these devices become autonomous and they can take decision while operating in the field. Next, please. This is also a very famous package called OpenVINO. It's a kind of breakthrough in this field made by Intel. Next, please. We have also spatial AI. This is a snapshot from a project running in Egypt to using AI with satellite images to identify the different areas, including agriculture places and the type of crops within these places. Next, please. This is another part of the project. So spatial AI focusing on AI in the context of GIS and spatial information systems. Next, please. Another kind is remote sensing models, which also related to satellite data. And the idea here is that you don't need to implant sensors into something like smart agriculture. Using images, you can identify the type of crops, you can identify the degree of humidity of the field itself without having any sensors implanted. This is also quite interesting domain, which uses computer vision and image processing. Next, please. Another example. This is a very important also use case for AI using remote sensing models, trying to provide risk management for financial services. So if you are an investor, for example, or a large investment foundation or organization, you want to move your investment into safe places, you want to avoid crisis, so you can use remote sensing to monitor and see what's happening on the earth, so you can decide where to go next or where to avoid. Next. We have also the conversational AI and cognitive models, which are trying, next please, which are trying to connect people to the cognitive models of humans. And this actually reflected in what we see in personal assistants like Alexa and virtual agents. Next, please. And finally, you have the breakthrough, the greatest one, which is ChatGPT. It starts with ChatGPT, but actually, as we speak, we have so many generative AI services and solutions. If we can go next, please. This is actually covering all domains like text, video generation, image, code generation, code development. Today, I have read also that ChatGPT is able to navigate the internet on behalf of a user and tell about the updates and news of a specific topic. So this is actually by all means is a very huge jump in the history of AI. The final one we have here is a kind of still under research domain, if we go next, please, which is collaborative AI. And this is actually my domain of research in university or Nile University, which we are working on a collaborative model using blockchain. The idea here is that enabling collaboration during the learning and building of the AI models. And this is expected to be the next frontier for AI. Collaboration among machines, agents, autonomous agents, and collaboration among humans and or between humans from one side and autonomous agents from the other side. Getting this holistic collaborative model for AI. Next, please. One example that is taking place as we speak is having collaboration between machines, like if you are covering a huge farming area by drones to observe for plants diseases, trying to do this kind of mitigation of risks, decisions related to harvesting and stuff like this. You can do this using drones, but the challenge is that you need to have these drones communicating with each other because they are covering all together collectively or in a collaborative way. They are covering huge, like 100,000 hectares. So they need to arrange the routes, arrange the coverage and stuff like this. This is an example of an existing collaborative AI, still immature, but it's working. Next, please. And the question now, why AI is different in terms of enterprise architecture and enterprise application. So at the end, AI is implemented as a software, okay? But this is some kind of privacy for AI. The first one is that, or the main point here is that AI is seen or should be seen on 3 different views. So when we say the word AI, it becomes confusing because it has been handled as just one thing. However, there are 3 different things. The first one, AI from a science point of view, which includes mathematics, statistical modeling, machine learning, deep learning, neurosciences, cognitive psychology, philosophy, even computational linguistics, among other topics. Next, please. The second view is AI model. This is the core part of any AI solution, like having computer vision model like CNN, object detection model, clustering model, generative adversarial network model. So these are the core part of an AI solution. And finally, next please, is the AI application view, which include different domains like what we have seen in the beginning of this presentation, like computer vision, image processing, pattern recognition, natural language processing, voice recognition, among many others. So these are three different views of AI. They are called all together AI. However, we need to segregate them. And for example, if we take the example of computer vision in a car or a self-driving car. So the scientific part is mainly deep learning. We are using deep learning, which is kind of machine learning models to learn how to identify elements of a video stream coming from the cam, in addition to also identifying the different movement and action taken by the car itself. This is a scientific part. It results in a model. This model is typically a kind of combination of CNN model and reinforcement learning model. So this is the model part. And finally, it's put into an application which is self-driving car, integrating all these elements together with a software application and hardware integration, and going forward just like any other application, but taking the core model, which is a computer vision model, and the reinforcement learning model, and put them into the core of this software application. Next, please. So actually, in handling AI, we have two, or working with AI, we have two main approaches. Pragmatic approaches go very fast and start to apply AI models whenever they pop up in the market. And next, please. The other one is idealizing more, trying to find out what are the risks associated, what are the dependencies, and looking for more of ideal model, especially when it comes to privacy, dependability, manageability of the AI solution, and what should work fine, or what we have seen from observation, actually to be in between. Next, please. To be a kind of realistic, which means to work lean agile. We need to take into consideration the consequences of implementing AI solution, as well as you need to go fast, because we won't be able to find to stay and wait for maturity to be completed. We need to make use of the opportunity of AI. But this comes with risks. If we go next, please. The most critical of them is responsibility. Who is responsible for, from one side, implementing AI models and make sure they are working fine, and also responsible for tracking the results of AI if things go wrong. And this actually happens so many times that things go wrong to a very extreme level, including losing lives and stuff like this. Next, please. And we have also the accountability. Who is accountable? How can set something or someone accountable for the results of AI if things go wrong? I'm talking about the negative side right now, the risks. For example, if someone is killed, who is accountable? Is it the companies that runs AI solution itself, or is it the developers who develop the solution and the AI model? So we need to find out how to do this, how to make this regulated. Next, please. We have also ethics and privacy. This is quite important. If, for example, you have ChatGPT now publishing papers, and people are using it to make money, and this is out of the intellectual property of other people. At the same time, we don't have any guarantee for preserving the privacy of people from leakage and being used or abused. So how to solve this, how to handle this is quite important. Next, please. GRC for companies. So we have with different vertical industries, we have governance, regulation, and compliance requirements coming from the government or international organizations. How AI will be handled through this, what should happen to the data used for AI, and the outcome decisions coming out from an AI solution. Next, please. We have also dependability. How much can we depend? How far can we depend on AI? If I'm an organization and have built an AI solution and launched some services out of this AI, and then some things went wrong, I have spent money, I have services offered, I have employees. So how we can manage this dependability of our solutions and services on AI? Next, please. And also we have manageability. Manageability also is quite an overhead. How to manage an AI solution, because actually the point behind AI, as we'll see in a coming slide, is that It's not one go. It's not like software applications. It's not like infrastructure solutions, technology solutions. It's not straightforward. We need to have iterations. We need to iterate first one to get version 1, version 1.2, version 1.3, and maybe things will go wrong with 1.4. So we need to go back and try to fix out what happened. So managing AI solution on a long term is also another challenge. And finally, you have sustainability, how to sustain AI solutions. It's related to manageability, but it's more of longer term and also including intercommunication between organizations. Because now, if I'm a company like OpenAI offering ChatGPT, and other companies and enterprises and organizations, maybe including in the future government, depends on my solution, and then I decided to stop for any reason or decided to change my policy, like what happened, bringing it from completely open source to closed source. How I will be able to sustain my situation under this variability of decisions or policies. Okay, so these are crucial risks need to be considered whenever it comes to AI. Next, please. So in terms of technicality, so typically we have different models and AI services, including the most recent generative one. We have models, platforms, services. It might be on-prem, it might be on cloud, it might be a kind of hybrid between the two situations. I might have part of the solution developed completely in-house, or might have it as a service through a provider. On the other side, next please, we have the value to the business. We would like to realize some value to the business. It could be on a wide spectrum, as we have seen, from simple perspective, simple to compare to the complex, simple perspective analytics, and up to computer vision and generative models. The most critical technical piece is actually the data. We go next, please. So the data is the critical part, because what we are dealing right now with, and the famous part of AI, is what we call data-driven AI. It's driven by data. We have other types of AI, like symbolic and rule-based AI, search and optimization, stuff like this. But the common one that is, on the table right now and making this kind of breakthrough is more of data-driven AI. And data actually is a core enterprise architecture pillar. So this is the first and the most critical connection to or interlock with enterprise architecture. How we'll be able to figure out new data architecture and governance, from governance and management point of view, that is suitable for AI. So in the past, we are using data for stuff like application development, reporting, business intelligence, dashboarding, visualization, and these are deterministic and straightforward. AI is unlikely, not deterministic mostly, and also it includes access to data from within the organization and data from outside the organization. So it becomes very critical how we are going to handle and work with data. Next, please. So if it comes when it comes to enterprise architecture, the very final outcome is a kind of a ICT application, which might include the four, or should include actually the four things we have in any enterprise. The main things we have in any enterprise architecture, we have the business, the applications, data, and technology. And when it comes to software application, normal software like CRM, ERP, core banking applications, even e-commerce applications, stuff like online services, we have two cycles. We have the application development, where we develop this application, including all the stack, the whole stack, and we have the implementation and sustainability cycle, which makes sure on a long term that this application will work and function properly, including managed services, for example, support, and new versions, new releases. This is actually has been handled greatly over the last decade with the emergence of DevOps practices. But what makes difference here for AI solution? What is the key differentiator? We have additional life cycle. If we go next, please. This additional life cycle is what I referred to in the beginning of the presentation, is the AI model development. Actually, what makes difference between a traditional or a normal software and an AI, data-driven AI software, is that we do have a model. This model is a combination of algorithms. Either it has been built using, or it is an algorithm that is running within our application. It depends on the type of machine learning or deep learning that has been used. The point here, if you go next, is that AI model development contains a high degree of uncertainty. Please go next. So the uncertainty here, because we don't know what is the model in the beginning. So we do have the data. We start to work with machine learning, statistical modeling, clustering, deep learning, operational research. Maybe we do have so many different techniques, but we don't know in the until we start execution and developing the model. We don't have a solution. We are trying to solve unknown problem using unknown solution, and we do have a wide range of algorithms, techniques, models that we can use to solve our problem. And it's driven by the data. We don't know upfront how it looks like. Definitely, you have accumulated experience from past projects and past solutions. However, there is no guarantees that one existing solution will handle the problem. We need to iterate, and we need to go into an additional life cycle. This is the critical part of an AI solution. Next, please. So if we look at enterprise architecture, and this is actually the masterpiece we have, it plays a master role for governance from one side, like having design authority for organization or for specific program or portfolio of programs and projects, and also it plays a main role for managing the process itself and making sure that these solutions are adhering to a kind of standardized set of architecture policies and values or principles. Under this, we do have the 4 main layers. If we go next 4 times, please. We have the business architecture, application architecture, data architecture, and technology architecture. We do have other point of views, depends on the framework, like security architecture, but these are the core and the main. And as I mentioned, data architecture is a critical part for this. However, I would say that AI is going across all layers. So it has requirements for business. We need to understand the business. We need to have alignment with the applications running already or coming in the future. It has implication with the application architecture, because it's at the end, it's going to be bundled and deployed within applications. It needs to be integrated with the application landscape at specific organization, or maybe sometimes even across organizations, several organizations. We have the data. Data is special because actually data here is the source for AI to learn from. And also, again, it's going to be integrated with AI. So typically, we need to integrate data sources with AI models to make sure they are continuously learning and adjusting. And finally, technology is definitely quite important, especially that for building AI models, we need quite extensive computational resources, typically huge distributed clusters or new technologies like GPUs and TPUs. Next, please. So one important thing that has emerged over the past 4 or 5 years and become a kind of de facto standard, it's also related to the architecture from one side and related to the machine learning, which is MLOps. As in front of us now is an example of MLOps cycle, which include 4 pipelines: data pipeline, machine learning pipeline, development pipeline for software, and also support and managed services operational pipeline. They are working as streamlined process altogether. And as you can see, this is one example from what looks like the MLOps tools used with Google Cloud. As you can see, it's quite huge number of tools, and this will add another complexity to AI solutions. We need to include this into our enterprise architecture and make sure that we are having proper interlocks with these tools and these processes. If we go next, please. So the project I'm going to talk about now as a use case. Actually, in Egypt, you have over the past 10 years, we have a digital transformation started with the government, very strong sponsorship from government. and it reflected in many applications transformed and many different projects, including full digital city, intelligent transportation system, implemented partially, but going forward. We have also smart agriculture transformation across the whole country. This is another project called Hudhud. We have also initiatives for digital healthcare. It's not yet holistic, but actually taking specific hospitals and specific sectors working with it. But it's starting, and a little bit of smart economic transformation. And finally, we have also the e-government. The e-services for e-government started to grow. Recently, we have citizen engagement platforms that extensively using AI and business intelligence to start to figure out the engagement level of citizens. The AI in Empower Egypt has used a different approach, which is a bottom-up approach. So instead of starting from vendors and huge industry leaders, we are starting from research and academia and government organizations, trying to build the capacity underneath and link this to the current projects that are working across the country. The first objective is to have this kind of industry academic collaboration for research under the supervision of Ministry of Communication and Information Technology. Next, please. And then we have objective of establishing solid working artificial intelligence AI use cases. So we have selected specific use cases that are aligned with existing projects, so they can add value. Next, please. And also we focus on the capacity, addressing domain applicable to countrywide. Next, please. Having the capacity is quite critical because it's again AI solutions depends on human skills, so we need to make sure we have proper capacity. Next, please. And finally, working with open data and open source technologies to make sure that it's aligned with the global direction. Next, please. If we can go 5 next, please. Okay. So these are the use cases. Plant disease for smart agriculture transformation, safe intelligent transportation for digital cities, surface quality monitoring for smart government services, monitoring the citizen interaction and complaints. And we have partially covered use cases, but this is for first year. Now we are starting second year of the project out of 5 years. We have also medical diagnosis and treatment in digital healthcare, focusing on cancer detection, breast cancer detection and skin cancer detection, among others. We have also a strategic growth for smart economy transformation, motivated mainly by what we have in Egypt as a shortage in foreign currency and also some complication with foreign investment. So these are the 5 use cases under focus, and we are planning to extend them. Next, please. So the idea of or the architecture, or the overall architecture for this collaboration, we have actually 2 main layers. We have the government represented by MCIT, and underneath we have AIC, which is the Applied Innovation Center. This is the implementation arm of the MCIT, converting innovation into applications. They have got resources like high performance computing infrastructure. They have calibers. We have industry vendors. Mainly, we have the leader for this solution in Egypt is Dell Technologies, and we have research universities. In the first phase we have 5 research universities and entities, including AUC, where Dr. Galal is working. Next, please. So this is the first layer. We have our clients actually are governmental organizations, smart government for digital transformation. We have hospitals for digital healthcare. We have a project for Ministry of Agriculture, another one for Ministry of Economic and Planning, final one for the Ministry of Transportation. So these are the actual real project running on the ground. Next, please. And so the first layer is responsible for innovation and development, leading and providing this kind of a framework to have those customers engaged. And then next, please, implementation and management go individually per each project. So these projects actually on the button here are already running and delivering results, but they are looking for the AI solution or component. Or sometimes they purchase it as a black box, which is actually is not a strategic solution. Next, please. So, and the idea here for to having this kind of collaboration. So this is a key point behind AI in Bar issue. Next, please. So the adopted approach actually is that we have already digital transformation is happening, and we do have enterprise architecture into two main layers: governance, and next, please, and management. This is actually, if we go another one next. This is actually an ongoing effort that has been deployed by the government. They are working with global experts and consultation offices. Some of them like Software AG, Pricewaterhouse, SAP, and they are mainly using TOGAF and Irwin as the tools and framework for managing enterprise architecture. And what we would like to do is plugging ourselves into this in more practical way. So what we have done as a framework, and this is definitely for year one under refinement, is that we started to think about how to make sure that this kind of ambiguity associated with artificial intelligence can be managed through enterprise architecture, taking into consideration that we have AI life cycles, we have MLOps life cycle, we have software development life cycle, mainly coming from lean agile point of view. And we developed a framework based on 18 milestones. So the framework here is traditionally we have phases, and inside phases we have deliverables, milestones, and stuff like this. We thought it's going to be much better and agile for and suitable for also for having this large number of collaborative organizations and people to work with more of a kind of flat framework. So it includes, if we go to next, please. It includes 18 milestones, and within these 18 milestones, we have mainly three phases: AI solution design, AI model development, which is a critical one, the core one, and AI application implementation. The point here is that we make flexibility for leaving these milestones flexible on two dimensions. The first one, how they will be integrated with the existing enterprise architecture, and the future one, because currently most of the government organizations are doing the exercise of creating an enterprise government, enterprise architecture office, as well as putting together the governance framework and the management framework, the architecture development lifecycle. So they are on different phases, on different stages. Not all of them are synchronized. Different vendors working in each or certain organizations. So having milestones instead of having another layer of life cycle with phases sounds to be in the beginning during the design as a more appealing solution and give flexibility. This is flexibility number one. Flexibility number two for the project groups and researchers working and collaborating on the project. They have flexibility to go back and forth among these different milestones until making sure that milestones are deemed complete. The milestones in the AI solution design, including creating a statement of work with clear vision and details of what we are going to implement. It includes also setting a project management for execution, mainly based on Agile. Domain understanding, having or ensuring that we have subject matter expert or expertise from the customer or from externally to cover the business domain itself. Having proper solution framing before beginning, including ROI analysis for the solution, and then putting together a design for MLOps, because MLOps is very wide term. And it depends on the type of projects, it depends on the type of AI domains that we are trying to tackle. So we need to, before spending money on building MLOps implementation and platform, We need to put a design to verify during the AI model development. And then sourcing data is quite important. How we are going to acquire the data from the different sources we have. And this is quite a complicated step in government, actually, because yet we still have a kind of regulation to come on how to exchange government data across government organization. And then in AI model development, we have the model platform. Modeling platform is quite important to secure a platform to execute AI models and train them. They are quite extensive, typically, in resources. If we don't have proper platform, things will stop eventually. Making data preparation is quite critical. Understanding data and reasoning data, and making sure we have proper quality of data. We have also model planning, model development, and model evaluation. These are the three different steps of modeling: creating the AI model, solving unknown problem using unknown technique and method. And finally, also we need in this phase to make sure that we have proper application development, because the application is mainly driven by the developed model. It makes a quite difference. Is it real-time batch processing? What kind of integration do we need? What kind of operational source data we need to put together? What kind of output? Where this output will be injected to make effect over the whole system. So application design is quite important at this stage. And finally, we have the application implementation, which include the production platform, making sure we have proper production platform specification and requirements. The operationalization means that we need to plan how to move the model from the development environment to the operational environment. What are the consequences? What are the additional requirements needed? Rolling out the MLOps. MLOps is our arm for sustainability. It should ensure we have continuous enhancements and delivery and operation of the platform, the AI model, once it becomes an application. And finally, we have the solution delivery, how the solution will be delivered and implemented up to be operational. And we have managed services, which include how this solution will be supported on long term. And finally, project closing. Next, please. The second important part is that we figured out that for any enterprise organization, government, and maybe also non-government organization, we need actually three core enablers. Three next, please. The leadership team for AI. So we need people or a leadership team who have got deep understanding of AI, not necessarily to become technical, but they understand the key differentiators of AI. We need also agile framework for managing AI solutions, which is actually the one I have showed on the previous slide. And finally, we need for AI initiatives, we need to think like startups. We need to use startup approach. If we go next, please. We need to make continuous clicks until we get the full picture, please. So the idea of making a startup, think of it that we are a huge organization, but when it comes to AI, we need to take this part, this solution or this idea apart and start to think like a startup. In a startup, we start with the innovation, the design thinking, making sure we have team skills. And we have three main pillars to work around as a lean operation. We have technology platforming, market development, and financial management. And within this, we have the agile as the key enabler for this. At the same time, on strategic level, we need to think about the growth and the securing funding for our solution, because actually the challenge with funding that when you go and ask for funding for AI, you don't still have a full figure what it's going to happen, and you cannot assert and confirm the results. You need to have it like going incremental, step by step. Next, please. And along with this, we have the key point here is uncertainty. We need to have four next, please. We have uncertainty on technology platforming, the market response. We have uncertainty about the growth, and accordingly, we have also uncertainty about the total funding. So we need to go incremental using the same idea of a startup. And within this journey, Next, please, we have priorities. We need to think. Next. I'm about to finish it. Priority number one, framing. We need to have proper framing. We don't want to rush into getting something from the market or some module or some model and just implement. We need to think about the innovation and novelty within the idea. Next, please. Two next or three, actually. Okay. And this will be reflecting on how AI is making difference to our organization and what is the expected outcome. Next, please. Next. Privacy and ethics quite important. We don't want to build solutions and figure out that it's not ethical. It affected the privacy of data. Next, please. We need to assert this from the beginning. Next, please. 4 clicks also. Regulation and compliance. We don't want also to build solution and figure and find out at the end we cannot operate, we cannot run in a specific region or country or globally because you are not compliant with a policy or regulation like GDPR. Next, please. Yeah, 4 next also. Transparency. Back, please. Are we designing explainable, fair, and rational AI? Can we explain what is happening, what is the actions are all about? Can we assert or trace the accountability for the actions taken by AI? Definitely. Next, please. Sustainable growth. Okay. Also, we need to make sure that what we are doing is have got a good or suitable ROI, and we have a path and roadmap to how we are going to develop. Next. Next. And finally comes the model. After all of this, we start to think about the AI model, making the AI model framed. We need to start to build. We start to bring in the data. Having our data scientists and AI engineer working on data to come out with these computer vision models or optimization models or whatever the kind of models that we are looking for. Next, please. These are technical stuff used for modeling. Next, please. Final one is next is AI application operationalization. This is the last mile for AI. If we cannot operationalize the developed AI solution and model, it becomes useless. Just like any other application. The challenge here is that having AI, or in other words, AI model is a separate component. It's not like just a piece of software we are integrating with a bigger software footprint. Okay, so this is why planning for how we take it from the development environment where we start to dice and slice with data to come out with this bunch of algorithms working together to how we are integrating this with our application landscape and ensure that we are coming out with value. Next, please. Next. Another next. These are examples of integration. It will make difference definitely if we are working with cloud on-prem, trying to integrate the model, taking this model from the cloud. So we can, for example, we can take a model already developed and built from AWS, or otherwise we can build our own model and deploy it to AWS, or we can build the model deployed to AWS as an example, of course, and have the integration of data with our on-prem data. So we do have many attributes in planning the operationalization. Next. So next, please. So as a key takeaways, the first one, AI is not one thing. It's several solutions, several applications, several domains. Next, please. Enterprise architecture is still playing the key role. However, AI is different. So we should not treat AI as just a piece of software that will be put and deployed into our architecture. We need to understand what is beneath AI. Next, please. National adoption, including working and collaboration across different entities. Because actually, if we are talking about a country, we are talking about thousands of solutions, AI solutions, and AI components need to be deployed. It's not going to fly with the traditional model of having vendors providing this. It needs more collaboration and leveraging the existing resources, especially innovation and research. So in other words, the startup ecosystem is quite important for something like AI, in addition to other stuff like or a bigger picture of digital transformation across a country. Next, please. Proposed adoption framework focus on integration or enabling AI to having smooth interlocks with AI. So we have enterprise architecture. We need to have governance still and manageability through enterprise architecture. However, we need to keep an eye on the privacy and the special attributes of AI. So these interlocks should come from having this kind of milestones, flat milestones that give flexibility from one side to the enterprise architects looking after a solution, and also for the project team who is implementing the AI part. Next, please. And the journey for realizing AI should establish a startup-like approach, because we need to move, we need to be realistic, not very pragmatic or not very slow. We need to have something in between. So startup-like approach is quite was actually successful. So over the past year, which is still the pilot year, we have around 500 collaborators from the research institutions, government, industry, and we have managed to come out with around 6-7 projects, different projects. Definitely not all of them are mature, but we have very good results. We started to link these projects to the actual customers. We started with the 2 projects for smart agriculture and for the citizen engagement and the quality for services. Next, please. Thank you. This was my last slide. I've taken 5 minutes more than my slot. But if there's any question, I can handle this fast. Otherwise, you are very welcome to connect on LinkedIn, and we can have further discussion.
Hi, we've got a question here. So
I've got a question around ethics and privacy and transparency of this AI models. How can we ensure proper governance around ethics and privacy concerns?
Ensuring the first part to ensure is to include it, okay? Because traditionally, when AI and data science stuff is started, and even before this, with stuff like normal analytics running with ERP and CRM, privacy was not a concern. The concern was compliance and regulation. Are we compliant with IFRS, with Basel II, with BCI? It partially covers the privacy, but the point here is that the first guarantee is to include the privacy and make it as a main building block of your enterprise architecture from one side as a design authority, and from the other side during the execution and building and working with the data. One way to do is to adopt a framework like, or a requirement like GDPR, because they cover privacy in a very good way, and a detailed way as well. So they have different acts to cover different parts of the privacy related to European citizens mainly, but it can be applied anywhere.
Especially for tools like ChatGPT, it's all limited by your own thought process. It's limited by thoughts. And how can you prevent a rogue agent going in and trying to explore for a new combination of DNAs or something to find out a new form of virus or something which can cause havoc to mankind? Those are the governing principles which are key concern nation as such.
Yeah, this is quite challenging, and I don't think it's solved yet. This is a big challenge with ChatGPT. So, and the change coming from is it emerged out of sudden. So, you know, it was not that planned. In other words, so for example, ChatGPT 2 and 3 and 3.5, these are the breakthroughs. They learned from the data of everyone, almost everyone on the internet until 2021, right? And they have learned GPT 3.4 learned from 500 billion token, considered like a word, 500 billion token. from
The stuff gets watered down. Sorry, as stuff gets watered down, the original authors will vanish. Yeah.
yeah, that's true.
And that's that
Yeah.
for me is a major, you know, how do we create new innovations? Because anything you put down on paper now is going to get ripped off. You know,
Yes.
it'll get watered down, it'll get ripped off. So that's a major challenge. Sorry, I'm just going to change this, but yeah, just one quick question. In all of the work you did, and I looked at your slide 23, you talked about solution delivery, but looking at your projects, there's quite a few projects. But I didn't see any mention of change management, because you're introducing new capabilities. But, you know, there's a massive change. When you talk about farmers, for example, you know, for them to start using the technology, that's a change program in itself. So it's the people. I didn't see that in slide 23. Is that part of your service delivery thing?
Yeah. The point here is that we are not responsible for the whole project. Yani, let's take, for example, this is a very good example, because actually farmers are far away from technology, except for mobile devices and using Facebook, social media, and stuff like this, which is quite good because the solution depends on mobile devices. But the point here is that the project for smart transformation is a project by itself. It includes this kind of training to farmers. I have attended some of these training in exhibitions. They bring them into halls, training rooms, and they start to use the application. But this is part of the project. We are also only covering the part of having AI capability embedded into these transformation projects. So what we are producing actually is going to be at the end integrated within the applications, and these new applications are going to be used and covered by the original project, and farmers are going to be trained to avoid or to overcome this culture barrier and having this kind of a change procedure. So we are not implementing the change because we are not interacting with end users. We are just embedding the overall project with the AI capability.
Yeah.
But
Thank you very much. I was looking forward to this presentation. It's good to meet you finally.
Thank you.
Yeah, I'm looking out for the work you're producing. I'm fascinated by the outcomes. Who's paying for this all? Is it the government? That's my last question.
Yeah.
Who's paying for it? Who's funding it? The government?
The government and Dell Technologies, yani jointly.
Dell. Okay.
Yeah.
All right. Brilliant. Thank you very much. That was really good.
Thank you so much. Thank you.
Enjoy the rest of your day.
Thank you. You too.
Bye-bye.
Bye-bye.
We end this. We went slightly over there.